Amplifiers, film number 2, and this is a very short version of how amplifiers are connected to form the specified amplifier that you want. You have two versions. One is called the inverting amplifier, and then in the next second we will go through the non-inverting amplifier. What you have is that you have the basic Opamp, the one we looked at the previous film, and then you have two resistors connected to it, and then you have some kind of supply, which could be, for example, a microphone, and you connect that to whatever load you want to connect it to, for example, a speaker. What you get there is that you will, as I said in last film, the current in here is basically 0. So therefore, the current that goes through here, through R1, must also go through R2. Therefore, you will get some kind of a seesaw effect, which means that the current on one side equals the current on the other side. Since we measure V out here, and you have point in the middle, and V in over there, you will get this kind of a middle point for the seesaw. So if the V in goes up, well, this one has to go down. So therefore you get this equation here, that V in over R1 equals minus V out over R2, because of this seesaw effect. The amplification is V out over V in, and we can rearrange the first part of the equation here to get V out over V in, and we will get this. So the amplification is minus R2 over R1, or if you like, V out equals minus R2 over R1 multiplied by V in. So if for example, R2 is 10 times larger than R1, well, then the amplification becomes 10. So for example, R2 over R1 equals 10 kilo ohms over 10 ohms, then the amplification becomes minus 10. So you take the input signal and you multiply it by minus 10. We will come back to in a few seconds what this minus sign, what that means. The other basic amplifier circuit is this. Again, you have the operational amplifier as the centerpiece of your amplifier. So this is the total amplifier, not all that. This is the total amplifier here, and inside your entire amplifier you have the centerpiece, which is the operational amplifier. Again, you have power supplies. You need power supplies to drive it, to drive the amplification, and you have two resistors connected to the basic amplifier, and those two are used to adjust the gain to the exact value that we want. Now the thing now is that you have output voltage here and the input voltage there, and the output voltage will, or the difference between this voltage and this voltage, will split across those two resistors, just like in this Kirchhoff's second law. So therefore you get this kind of lever effect where you have V in here, which will also mirror over here, and that will be the same as the voltage divider of V out. So therefore you get this lever effect. I will go through that very thoroughly in the classroom, but here just the end result is summed up. Now this equation here is basically what the illustration here shows, and if we do rearrange this to get V out over V in, which is the amplification A, you get this as a result, or also it can be presented like this. So it's 1 plus R2 over R1. If you use the example here from the last page, where we had that R2 is 10 kilo ohms and R1 equals 1 kilo ohm, then we will get the amplification is 1 plus 10k over 1k, which is 11. Not a minus sign, there's a plus sign here if you like. Now what does that mean? The plus sign and the minus sign. Well, let's look at if this blue here is the input signal to the amplifier. If that is the input signal to the amplifier, you amplify it by a factor so it becomes larger. The output is larger than the input. But if you have an inverting amplifier, you see when the input goes up, the output goes down. When the input goes down, the output goes up. So they are opposite of each other. A non-inverting amplifier will have that the two waves are synchronized. So when the input goes up, the output goes up as well. For an inverting amplifier, they are opposite. For a non-inverting amplifier, they are in phase with each other. For most practical purposes, it doesn't matter. If you play a sound on a speaker, you cannot hear any difference if the signal is inverted or non-inverted. What you hear is that it's amplified, it's stronger. If you see here in this example, it looks like the input signal stretches over 2 dividing lines, while the output signal stretches over 6 dividing lines. So the amplification is 6 lines over 2 lines, so it's 3, which means that the output signal is 3 times stronger than the input signal. However, we need to have the minus sign as well to illustrate that it's inverted. This one, output, the non-inverting amplifier stretches over 4, the input signal, while the output signal stretches over 8 dividing lines. So it's 8 over 4, so you have a gain of 2, or an amplification of 2. As shown in both figures here, the non-inverting amplifier has power supplies, and the inverting amplifier also has power supplies here and here. And as mentioned in the first film here, first page, you need a power supply to drive the gain of the circuit, to drive the amplification. What happens if the supply is too small? Well, the output signal can never exceed the supplied voltages. Remember that the plus supply is the one that lifts the output signal upwards, and the minus supply is the one that pulls the output signal downwards. So if you try to achieve an output signal that is larger than the supplies, you will get something called saturation, which is that the output signal is kind of flattened. In most cases, actually, there will be a small gap between the supplied voltage and the maximum output voltage. So you can never achieve a higher output voltage than the size of your supply voltages. Output max is the supply voltage plus and minus.